All right, so let's go ahead and get started with this next breakout session. This session itself is color 3D printing more than just for cosmetic purposes. So throughout this session, we're going to be looking at alternative uses for these additive manufactured parts that have color incorporated into them. We'll be looking at the printer itself, different use cases, and different scenarios and manufacturing strategies that could take advantage of it. Now, before we get going with this presentation, just want to give a quick reminder. On the right-hand side of your screen, you're going to have a chat column and a question and answers column. I would highly encourage anyone who has a question to make sure you toggle into the Q&A. We actually have Austin Smith and Brandon Brown on the line, two of my colleagues here to answer any of the questions that come up throughout this presentation as we're looking at color 3D printing. If you do answer there, it'll be easier for everyone to look at those questions and ask away. Another housekeeping tip, I do want to thank HP for sponsoring this breakout session. If you haven't yet, make sure to stop by their booth, ask any questions about their line of 3D printers, either their 300, 500, 42, or 5200 series, especially at the end of this presentation after we look at different uses of color. And then finally, as one final housekeeping tip, I'd like to introduce myself. My name is Mark Dolinar, and I'm an applications engineer with Hawk Ridge Systems, and I specialize in the additive manufacturing side, focusing primarily on our HP and Markforged line of 3D printers. And that's where our talk really begins. So HP released a full color spectrum printer back in 2018 called the HP Multi-Jet Fusion 580 machine. And what that machine really allows you to do is create full color spectrum parts that not only look pretty, these are fully functional parts made out of a PA12 material. So they're extremely tough, extremely durable. Now you can see on screen here, there's multiple different examples of how color printing is currently being used. From things like the anatomical model of a heart. This was actually made from Children's Phoenix Hospital. Basically, they use this in order to walk the patients through a procedure that's about to occur. To maybe even a cast that a kid is more likely to use because, well, they have a cool logo or a texture or maybe even a comic character directly on it. And there's also various types of examples like cell phone cases or even these end-use parts. And what I always hear a lot when people first see a 3D printed color part, well, that color looks great, the part looks great, but in my manufacturing setup, I really have no need for color. And that's where I want to challenge each and every one of you on this line. By the end of this presentation, hopefully there's some new ideas of ways to incorporate color directly into your product line. So let's actually start off with something. How do we communicate? With every product and manufacturing approach, we're bound to have design changes. And typically, communication is done in one of four ways. We'll send emails or direct messages to a person or our manufacturing line. Maybe we'll even call them and tell them about the change over the phone. Or other times, if they're on different time zones or different locations, or maybe if it's even a customer, we'll actually try and send them documentation about different installation processes or different warnings when working on the equipment. Now, all this is great, but sometimes that communication can be lost in these means of transportation for these messages. So real quick, I actually want to take a quick look at an example that really has nothing to do with color, but has everything to do with communication. On screen here, we have an airline ticket. It's something that most of us have used in the past. I know not a lot right now, but this is a great example of clear communication. This one ticket gives you all of the information that you need to make it to your flight on time. So the information like the airline, the airport, your destination, your seat number, your gate number, all this information wrapped up into one piece of paper. So let's run a quick experiment. On the right-hand side of your screen, you'll actually have a column that's called polls. I've actually just launched a poll right now. And go ahead and look at that poll. What do you think the departure gate was of that ticket? Give you guys a couple seconds to make a couple of guesses. And let's see what you guys come back with. So we're getting a couple saying B19. We got one saying F4. We got three saying F4 now. And it looks like the other ones don't have any selections. Oh, it's about tied, about 44% going B19. The other half is going F4. So we're already at a discrepancy with just that one piece of information. We've got a couple other answers that are coming in now. Well, let's take another look at that ticket. So if we look at this, I'm sure that some are going to be able to easily identify that departure gate directly on the fly, where others might actually take some time to try to figure out what the departure gate is. If we really look at it, notice they put that really critical piece of information in the bottom left-hand corner of the ticket. Definitely causes some confusion. And if we look at the poll results right now, notice that most of the polls, actually right now it's about 45% of the respondents said the gate is 19B. So had you been at the airport and again, quickly glanced at a ticket, maybe you're running late to a flight, you look down at this ticket, you see 19B, that must be the gate. You run all the way over to B19, only to realize it's the wrong gate. And realistically, you're in the wrong terminal, so you'll miss your flight. That's an important piece of information that, in this case, wasn't really communicated all that well. Well, in manufacturing nowadays, there's different manufacturing methodologies that are trying to improve the way that we communicate with one another in order to reduce errors or make it easier to find the critical piece of information. So in this case, this is a ticket, the exact same ticket, just designed around like a lean manufacturing approach, where it's produced in a clear and concise way. If you looked at that ticket right now compared to the previous one, it's much easier to find the gate. And it's much harder to mistake the gate for the seat number. Now, they do this in two ways. It's much more organized, but they also use pictures and graphics to convey a point within that particular picture. So in this case, that communication chain is actually strengthened with the use of graphics and pictures. So I want to take a second. This was a really quick poll with one sheet of paper and only a handful of information. That second time around, when you were looking at that plane ticket, how long did you actually have to spend in order to find the gate number? And then think about this. When you're dealing with complex documentation and assembly instructions, and you send that information down to the shop floor or to your customer, how much time are they taking to find a critical piece of information, such as the bolt that's required or the torque setting? And then how do you extrapolate that out throughout an entire year? Definitely see the opportunity for downtime and for mistakes being made with our current communication structures. Now, everyone's heard the saying, a picture is worth 1,000 words. And I would argue in manufacturing, it's actually worth much more than that. Because with the use of pictures, graphics, and colors, we can clearly communicate what our end user, our technician, our customer needs to do and reduce the amount of errors by simply adding very small pieces to our current parts and our current product line. For example, this is a mass airflow sensor adapter. You're supposed to put it on an engine, and you'll notice that the adapter itself actually has a port on top and on bottom that is the exact same size. So if a assembly technician were going down the line and grabbing this part, it's very easy to accidentally put it on upside down. Now, when you're dealing with individual sub-assemblies, you can assemble this wrong, put it together, and the entire sub-assembly will work. That is until you get to the next stage in the manufacturing process, or if you send it out to your customer and it's installed backwards. That sub-assembly component will work, but notice how these ports are actually off at an angle. And that's to clear other components of the engine. So had this been installed upside down, the next stage and the next guys over there that are dealing with this are now going to have to undo the work, put it back together, and then continue on, causing delays in the manufacturing process. Now, traditionally, this is probably going to be injection molded. So we're kind of limited to one color for the entire part. But what if we could add some simple pieces of information, such as like a graphical arrow showing what direction this part is supposed to be placed? Or why don't we even color the ports and color match those to the hoses that are supposed to go on those, reducing the likelihood of someone assembling this wrong? Traditionally, when we look at machining or we look at injection molding, adding information like this requires additional steps in the process, either using stickers or taping it off and applying paint. But the beauty with additive manufacturing is we don't have to wait any longer. As we're printing this part, we can just print the color on the part as it's being produced, opening us up for more opportunity. Let's look at another example. In this case, this is an electronics housing enclosure. Nothing too special about this, and you'll notice this is a really unique shape. So unlike that last example where you could technically assemble it wrong, this one's not really that hard to assemble correctly. But there are different requirements for the bolts on the front and on the back due to what's mounting below it. And if you're new to this particular line, it's really easy to grab 4 bolts that are the exact same length and throw it directly on this part. Again, it might not affect you at your station, but later on down the line, it could cause some large ripple effects. So again, why can't we do something really small, like put graphics directly on the part with what type of bolt we need at that particular location? Again, with traditional manufacturing, we would have to apply a sticker or paint this, but with additive manufacturing, we can just produce the part with these graphics directly on it. Another problem that I see quite often is dealing with assembly lines where you have multiple different parts at multiple different stages of the iteration process, especially if you're going through like a prototyping phase. You'll see on here, we actually have 2 of the exact same parts, but at different stages. So the part on the left might be Rev A, the part on the right might be Rev B. Visually, these 2 parts look the exact same. However, if you actually take a look at the differences, they're actually very subtle. But if you have a stack of these parts sitting right next to each other, it's very easy to grab the wrong part, throw it on whatever you're building, and then ship that out the door. Now, you won't find that problem until later on down the line, and the cost of that mistake starts to compound, especially when you've shipped it out, sent it to a customer, and maybe you need a technician to go out and replace it, or you have to send your customer a replacement part for just a simple manufacturing mistake like grabbing the wrong part. So why not just add a touch of color to that new part so that your assemblers or your technicians know that this is Rev A or Rev B. And notice on here, I added the color around the ring on the bottom. That's something that we could easily go through and hide on the final part with maybe like a gasket. So no one would ever know this is our color technique in our manufacturing process. So at the end of the day, with all those examples from the plane ticket to those two components, what we're trying to get to within manufacturing and product design is a easier way of communicating ideas or instructions directly down the line. When I was researching for this presentation, I actually found this pie chart, and I thought it was actually really interesting. When you look at this, these are all of the various reasons we have for manufacturing downtime. Now, some of these are really out of our control, and there's not too much that we can do with those. But others, I argue, can actually be incorporated into the part design to solve them before they even become an issue. If we look at the pie chart itself, human error and training deficiency make up almost 40% of the reason for manufacturing downtime. And both of these can technically be solved with adding more or clearer communication to your existing parts. For example, human error. If you have an arrow pointing which way a part needs to be bolted, what type of bolts, what the torque settings are for that component, there's no reason that someone's going to assemble it wrong. Training deficiency. When you go through and you're trying to learn about a new process, or you're trying to learn about how to assemble something in a class or a webinar, most people can't retain 100% of that information. So when you're going through, you might miss a step. And that misstep can cause some backlash in the assembly process where you're now having more and more errors and problems. So again, why not just add the information that the technicians or our customers or whoever is working on our products needs directly on the part itself? So at the end of the day, if we can figure out a way to better communicate throughout the entire life cycle of our product, we can reduce our costs. We can ultimately make our product more productive in the assembly line. It'll make it easier to repeat each process, and our quality is going to go up. And then finally, with instructions built directly into the product, we can technically have a lower required skill to assemble or work on our products, making it easier to find people to employ. In modern manufacturing these days, there's different methodologies and different approaches to making our manufacturing process smoother, better, more efficient. From lean manufacturing to Six Sigma to 5S. Now, I don't want to get into those manufacturing methodologies, but all of those use color or you use logos and graphics in one way or another. For example, when you go through and get bar stock from a mill, a lot of the times they'll actually spray paint the end of it, indicating what type of material it is so that your machine shop doesn't grab one round bar versus another that might be, one alloy versus another, limiting mistakes. Kanban systems use color all the time to order and prioritize different parts in their sorting system, making it easier for whoever's trying to run and organize their system to find components or ship them out or whatever they need to do. You also see this a lot with inventory, where companies will actually color code inventory so that they know when they need to order a new part or new replacement part so they never run out of stock. And then finally, a lot of manufacturers are using color as a safety device, where you can actually look on the factory floor, know exactly where a fire extinguisher is, or maybe even a first aid equipment station by simply looking, glancing at the color and knowing exactly where to go. Extremely helpful when you're dealing with a high stress situation and you need to find that piece of information fast. Glance up, find the color, and go. And even HP incorporates color directly into their machines. For example, I was working on the HP 4200, and you'll see this is a picture of the print heads inside the machine. I was walking through with a customer and teaching them how to replace a print head when they need to be replaced. And we got to the stage where I was showing him the print head itself, and I said, just remember, anything that's colored blue is a touch point, and anything that's colored in orange needs to be removed before you install it in the printer. Now, he looked at me, and he took a step back, and he said, that's so incredibly simple. I need to start incorporating this into my products. And I kind of thought about this. A lot of the times we get so ingrained into the way we typically do things, especially when we're designing our products, we know everything about the product itself. We know how it's supposed to be installed. We know how it's supposed to be used. But when you start handing off that information to others, that's where that communication barrier might lie. And by adding things like this with a little bit of color around the areas that need to be removed before it's installed, you can eliminate errors before they even occur. Now, HP's really adopted this full bore. For example, this is a picture of their 580 printer. And if you zoom into the printer itself, every touch point of the printer actually is highlighted with a blue sticker showing where certain compartments are supposed to open or where you're supposed to grab to replace a component, refill material, or refill ink. So even if you've never used a printer like this before, it makes it that much simpler to figure out the way around it without too much additional help or too much additional skill. Now, you might be asking the question, with all these examples I'm showing you, they all have to do with traditionally manufactured parts. So whether it's that print head cartridge where the parts that are injection molded are dyed one color or another, the Kanban system has colored parts that are dyed, the safety board, the bar stock all has color, and even the HP printer has some stickers on it. So why do we even need to think about additive? Well, that's where we actually look at the manufacturing cost. And additive actually has a very unique value proposition within the low to medium range of production. So usually for a part that's injection molded, you can actually get some very complex designs out of it, which over time makes the part very cheap. But the initial start cost of that part can be very expensive because you have to actually have the mold created. So you're dumping tens of thousands of dollars to actually machine and manufacture the mold. The other disadvantage of injection molding is whenever you need to make a change, it can be very costly. And if the change is too great, you might actually have to scrap the old mold and redo it again. Whereas in additive, if you notice a problem that requires a change, you can just change it on the fly. No harm, no foul. It's not going to cost you any more to make that change. Likewise, with machining, the setup costs for machining can be quite high when you're doing one part at a time. Now, it reduces over time as you're machining more and more parts within these larger assemblies. But again, the part cost always comes very close to what you can print the part as. So a lot of the times when you're looking at creating a new product or making a new fixture, additive actually makes a lot of sense at the cost aspect. Now, nowadays, with 3D printing technology being where it's at, we no longer have to worry about parts being only for prototyping purposes. The parts that are coming off of our HP machines are full functional parts. And you have a wide variety of different materials that you can use. So PA11, PA12, polypropylene. And they can all be used after printing. There's no additional post-processes needed. The other big advantage of printing is the productivity. You can actually print an entire assembly in one go. Most of our printers take an average of like 15 hours to print an entire run. So there's no need to actually send it out to someone else, wait for the shipping to get it back. So ultimately, we're getting these parts faster and at a much reduced rate. So again, let's look at those parts. All these parts were coming off of our HP Multi-Jet Fusion 580 machine. They look terrific. They have a full color spectrum directly applied to them. And we can use that part as we see it there, as it came off the printer in our setup. So real quick, before we get any deeper into talking about more uses, let's take a look at the printer that's able to create these products. This is the HP Multi-Jet Fusion 580 machine. So it's a machine that was released in about 2018 that allows you to create full color spectrum parts. These parts are printed in a PA11 or PA12 material. And the great thing about HP is they give you a voxel control system, meaning that you can control exactly where material or color is applied in 3D space. These printers are also a powder-based unit, meaning there's no need for supports. So you can create very complex geometry like lattice structures, and you don't really have to worry about trying to remove all of the support material from inside. The powder itself will hold and support it, and then as you remove it from the printer, all you have to do is remove the powder. Now, the Multi-Jet Fusion process, again, this is a powder-based system. So what you'll actually see is a spreader will come across and lay a thin coating of powder of about 80 microns. After that's been done, HP actually has their print head technology that they've been working on for decades. Now, this print head will actually allow you to apply two different types of agent, a fusing and a detailing agent. The fusing agent, when it comes in contact with a UV light source, will actually cure and fuse together, whereas the detailing agent will not, allowing you to have very crisp and precise details around your entire part. So once the printer has done printing, you'll actually see at the end, you'll have a fused part on one side and then powder that's left on its own. Now, these HP 580 printers are an all-in-one unit, meaning that there's no need for any additional equipment minus a media blaster to clean off the parts. You'll actually load the powder, load all the agents directly into the machine, send your print job to the machine itself, and it'll do the rest. The fusing, the laying the powder, and the UV light. Now notice in the middle of the screen, you actually have the build bed moving down, allowing you to stack as many parts as you would like on that build area. This video itself is actually shown in real time. And notice, we're actually not fusing one point of our part together at a time like you would on most other printers. We're actually fusing the parts layer by layer, giving you incredible strength and almost isotropic properties directly from the print itself. Now, finally, once it's all done, the machine itself will actually vibrate and vacuum away any of the excess powder, leaving all that's up to do for the operator is to reach inside and grab those parts away. Now, we usually recommend to dust away any of the excess powder. That way, the printer can reclaim that powder and lower the cost. These HP 580 machines can actually reclaim up to 80% of the print powder being used. So you can really start to reduce the overall cost. And you'll notice that after these parts have come out of the printer, all that's left to do is throw them into a media blaster, take away any of the excess powder, and what you're left with is a really nice, precise part directly created in hand. Now you'll see on this printer right here, those parts actually came out in full color. Most who've seen demo parts from HP have seen parts that come out like this, in this just typical gray state. Now, these are the way the parts come out of our industrial series printer that do not have the color option. But even then, you do have additional post-processing steps that you can do. For example, this is a great example of working with a full-size car bumper that was printed entirely off of the HP Multi-Jet Fusion line. You can see on the left-hand side the different segments of the bumper that were printed individually. They were actually glued together. And then you can see the various stages of the post-processing. So anywhere from Bondo to primer to sealer to the actual paint and then buffing. And if you look at that bumper, had you not seen the actual raw material, there's really no way to tell this was actually fully printed. So these post-processing steps that you can do with traditional manufacturing, injection molding, machining can also be done directly on these additive parts. But I would argue that's really not the way to best utilize these machines. For example, if you were going to take one of these parts out and dip it in a dye bath, it takes an additional time. Likewise, going through and trying to paint the part also takes some time. So though these post-processing steps can be effective in applying color directly to the part, they really aren't all that valuable when we have the technology to print full color. These post-processing steps can be labor intensive, especially painting, because now you're sanding, you're filling, you're putting Bondo, trying to make the surface look good. With dyeing, you're limited on the detail. You put the part in, whatever color the dye is what you get out. Now, you could add stickers later on, but stickers are going to wear over time. Likewise, when you start to scale these productions, because all these processes are very manual, you need more and more labor to apply the color and apply the detail. And ultimately, the operator is the one who determines what the quality of these parts are going to be like. If you have a good painter, they might lay down paint and it looks like glass. Others might actually have specks, may have orange peel laid in the paint. And then finally, all these post-processing processes need cleanup. Whether it's the dye bath or painting, you're going to create a mess within your environment. Now, with the 580 machine, they actually taken the MJF technology and applied a bright fusing agent. That's that white surface you see directly around the outside of the part. So this white fusing agent actually has a bit of titanium dioxide, which gives it that white appearance. And that's directly where the color is actually applied to. So your color, your texture, your graphics is applied directly to that outer layer. As you look inside of a regular part made directly off of the 580, if you don't have any color, it'll just show up white with that bright fusing agent as you see on the picture. But when you apply color, you'll actually have the color impregnated directly into the bright fusing agent, making your part a little bit more durable. And again, because it's now impregnated into the part, that can actually wear, and the color is not going to come off by just taking off the outside surface. So these parts are giving you incredible looking designs. You can put whatever colors you would like on them. But where does that actually fit in? And how does color assist in modern manufacturing? Well, let's take a look. This first case study is actually dealing with a company that deals with a lot of electrical wiring harnesses. And as you can see on the picture right here, these wiring harnesses can be extremely complex. So the company was trying to look for ways to improve the technician's workflow. One way they did that is by designing these connector holders. Now, the connector holders themselves were actually created out of a Delrem material, and they were machined, outsourced, shipped back, and then assembled. Now, the company itself was actually running into issues where if they needed a new holder, they switched lines, or maybe one broke or got lost, they would actually have to wait and actually pay a lot of money to get these parts created. And when you look at it, especially when you're outsourcing parts, a lot of the times you got to pay for either the time or you got to wait to get a cheaper part. And that's exactly what this company was doing. If they needed a part fast, they could go down the road, get it machined in the US, but they were paying a ton of money. Whereas if they went over to China, well, the parts could be really cheap, but the lead time was very long. So their planning needed to be on point, or else they were waiting for the parts to come. And that's where they actually looked at additive manufacturing as a way to kind of solve these two problems. Now, the great thing about the design that they started off with is it was created to be machined, which means when you're throwing it into a MJF printer, there was no real need to redesign the part. So if you needed it in a pinch, you could actually throw it on the printer, print it, and use it as is. Now, again, you're not optimizing it for additive manufacturing, so the part might be a little bit more expensive than it could be. But if you need it in a pinch, it's a great option. Now, ultimately, this part is used to hold the harness into place, to allow the technician to put all the electrical wires in, maybe wrap the cables around, and just help in the process of creating that electrical harness. But if we look at this part and try to open up some new doors that are now available to us. So in this case, this is how the part came in. And they were looking at using the 580 machine as their printer. So we could print it full black. It's not going to help the technician anymore. What are some things that we could do to make this part easier to view or to use? Well, let's start off with one of the technician's biggest problems. With these wire harnesses, a lot of the times they have bins of electrical connectors sitting right next to them. Some of these are much different than others, but sometimes they're very similar. And it's easy to make a mistake and grab one versus the other and not realize it till later on. So why not just make it easier on our technicians by applying a picture directly to the part so that they can create a quick visual check before they start using this connector holder. Now, likewise, notice you still have the serial number they can reference there, but how much easier is it to look at a picture versus a serial number to double check what you're doing? Another thing they need to do is wire all the electrical wires directly into these pins. A lot of the times, this can be a little complicated, especially when you're looking at a 2D wire diagram and trying to go back and forth between 2D and 3D. So again, why not just add a diagram directly to that connector holder to try and make it easier for them when they're assembling it? There's no need to reference another external diagram. And maybe if we're changing our design or changing our revisions, we can just change it directly on the part as we transfer from one vendor to another. And now this really leads to a manufacturing methodology that's super important and works really well with additive technology. But before we get there, just real quick, I wanted to run through the cost of this part. If you guys were curious, this connector holder itself ended up being about $15. When compared to the original part, that was about $900 to actually outsource and machine because of the low production run. They were able to put about 60 of these into a printer at one time. And the total time for a print was only about 18 hours from design to part in hand. Now, I do want to talk about poke-yoke. This is actually a manufacturing approach that's trying to reduce the amount of errors inside of your manufacturing process or your part line, basically mistake-proofing it. Now, this was adopted and invented back in the 60s by an industrial engineer at Toyota, and they were trying to figure out ways to make mistakes not even possible because of the way that they're designing their parts and their components. And we see this a lot in modern day. For example, a washing machine. When you push go, If the door is open, it won't allow the machine to go on, so you don't risk flooding your washing room. Or if you look on the back of older computers, color was used along with different size plugs. So as you're hooking up your computer, there's no way for you to hook it up wrong. When you're dealing with low volume production, sometimes it's very difficult to do these one-off connectors. But with additive technology, because they reduce the total cost required to make a part, you can start customizing your designs so it's color-coded and you have different slots that are designed to go in only one place to try and reduce errors. Here's another great example. Our printers have a lot of large moving components inside that need to be held in place while they're being shipped so that they don't vibrate and are damaged in the shipping process. Now, those components are actually kind of bolted together inside of the machine. And when the technician goes to install the machine, they go and remove all of those supports so that the machine can move freely inside. But some of those supports can be a little bit difficult to find, especially if it's in a color that's similar to the machine itself. And ultimately, if that happens, when you turn the machine on and start running it, it might collide and it could damage the parts that we were actually trying to protect with these components. So if you look at the picture right here, for a mounting bracket or a transportation device, which one's easier to see if you're looking at it as a technician trying to install a piece of equipment? Obviously, you can do a quick visual of a machine. If all the parts are gray, it's very easy to pass over. But if you have bright, dynamic colors, you can see that, hey, I forgot to remove one of these brackets, and you can protect the machine before it ever gets turned on. Now, the great thing is, because we're combining this with additive technology, each one of these brackets can be customized for each application. So if we have one customer asking for certain options and another one not, there's no worry. We're not committed to producing a large batch of these just to reduce the cost. We can just print them as we go. Why don't we look at another example? This is a company, Satair. They work with Airbus, and they were actually looking for an aircraft flap lock tool. Traditionally, these tools can be thousands of dollars. And they're extremely important. When they're working on the plane, they need to lock the flaps in place so that they don't move. But the tool itself also has to be a bright color so that they don't accidentally try to use the plane with the tool in place. So they actually came and used an HP multi-jet fusion printer to print off this tool. Now notice, you have that really bright dynamic color, so you won't forget the tool's there. You also have a cheaper part with the stickers or the diagrams or the angles that you need in order to use the tool. And there's no additional post-processing needed to paint, to dye, to apply stickers. This came out of the printer just like this. Now, there's a quote I read from engineering.com, and it said 70% of companies admit they lack full awareness of when equipment is due for maintenance, upgrade, or replacement. And what I usually ask is, how much is that actually costing an organization? Why not just apply color directly to the wear points of our parts? So for example, if this was a part that was supposed to protect a more expensive piece of rotating equipment, we could actually just color code our wear components. Once the color is removed, we'll know that we need to replace that component. Now, this particular example was actually used in a prototyping case, not to protect components, but they were trying to test different locking mechanisms. So they colored, one version red, one version blue, so as they're going through and testing out the part, they could see which ones wore better or more evenly than the other. The other thing that we could do is actually have this as like an infill testing. So if we're changing our part design as we're shipping out to customers, we can color code the different revisions so we can get data as those parts break or wear of which ones are causing issues and which ones aren't. Manufacturing aids are one area that I think color is exponentially important. In this case, this is a robotic arm gripper. And you'll notice that there's a pink and a green tube. Both of those actually are air hoses that need to be put into place. Well, there's two different colors on both sides, and they both go to different outlets. Why not color code it to prevent the errors from happening? We actually have this robotic arm gripper. Now, you'll notice that this actually takes the poke-yoke approach, where you can only put this in one way, so to prevent errors. But look at the difference. Which one's easier to view right off the bat and get a sense of what's going on? And how much time would that be saving us by just adding a touch of color? Again, for a gasket installation tool, if this is supposed to go in one way, why not just put a large red arrow of the direction that this is supposed to line up as? And then finally, this is actually a tool that HP uses for their 2D printer production. It's a fixture / go-no-go gauge that they've pretty much adopted full color with multi-jet fusion technology in order to help assemblers throw the parts on and keep it together. Finally, why don't we talk about the end consumer and making their user experience that much better? A great way of doing this is with QR codes. How many times have we been frustrated trying to find a replacement part only to not find the right part, read the wrong serial code, and order the wrong part? Why not just put a QR code to make life that much easier? We can also use the QR codes in manufacturing to link instruction manuals to, maybe to trace the parts and see what parts are going on to what customers' equipment or processes. And then finally, we can also use this to track inventory to make sure that we don't run low. The end consumer as well can benefit. Once again, ordering replacement parts, maybe optional extras. And especially with the Internet of Things taking off, why not make the installation process for the software that much easier? Now, of course, we can put QR codes on as stickers, but stickers can kind of wear off and fall off. This is impregnated directly into the part. So as the part wears, that logo is still going to be there. Color is being used in more and more manufacturing applications and more part aspects. So what areas could we apply color into our current designs? So to wrap this up, currently we use a variety of different approaches to communicate ideas or to tell customers or our employees how to manufacture something. But why not look at applying color to that list? So I'd like to challenge every one of you that are on this call and see where could color benefit you and your product or your manufacturing process to help prevent and solve some potential errors with downtime. So I'd like to thank you all for attending this breakout session. Once again, I would like to thank HP for sponsoring this session. There is one thing to note. If you are interested in HP's line of 3D printers, they're actually hosting a live event on October 20th, where they'll go through all of their multi-jet fusion printing technologies. They'll kind of walk you through an end-to-end workflow, and this is all live. So you can see in person, ask any questions that might arise from this. Once again, stop by our booth at the expo for the HP if you guys have any questions about this. So finally, thank you all for attending. I'll answer some of the questions as they come up. If you are interested in any more information, take out your cell phone and take a quick picture of that QR code on the side. It will pop up the HP page of our website to give you some more information on the 580 series printer. All right. So looks like we got a couple of questions from Mika. The first one is the powder safe for handling without personal protection equipment? And yes, the powder itself, for the nylon powder, you can actually handle without it. It's rated to be non-hazardous to humans. Sharon actually asked a question about residual powder and can it be reused? And that is a great question. So HP is actually able to reduce the total part cost of the printer by allowing you to reuse the powder. A lot of the times when you pack a build directly on the HP printer, you might only have a pack density of anywhere between, say 7 and 15%. Now, with that, you would have, however much more powder that would just be thrown away. HP does allow you to reuse it. They'll actually clean out the powder so you can print again and again with it. The reusability rate is about 80%, and that's one of the reasons why the total part cost can be so low. Okay, and let's go ahead and ask one more from David. He's asking about what the time difference in manufacturing a part, injection molding versus 3D printing. So it really depends with that, whether or not you're starting out with a mold already created, or you need to still create that mold before you can ramp up with 3D printing or with injection molding. If you don't have a mold created, sometimes the injection molding process actually can take weeks or even months of just the lead time to have that mold created. Once that mold is done, the injection molding can be extremely fast. Sometimes the cycle times can be seconds to 30, 40 seconds to maybe like a minute or so from where you inject the hot material to where you get the part in hand. A great thing to look at is if you are looking at injection molding, additive technology can kind of fill the gap between the point where you build or you commission the mold and the time where that mold is ready to be used. You can actually print the parts in that time period, so you're not wasting any time in that cycle. And then once the mold's ready to go, you can transfer over to the mold and then go from there. Cool. All right, and then we'll have time for one more. So Joseph just asked, is there any desktop version of this printer? And the answer is no, there is no desktop version. The smallest unit that we have is actually the 300 series. It's made to actually fit within very small spaces. I've seen them actually positioned within an office building. I would say if you look at like a standard size desk, it's roughly the size of that. So if you have that much space, you would be able to fit it. But at this point in time, there is no just desktop unit. If you're interested in desktop units, Mark Forge does have a couple of lines there. And one of our other guys, Kanan, will actually have a presentation about their Mark Forge line of 3D printers to cover those desktop units. But with that, I think we're at the time limit here for our presentation. I do want to thank each and every one of you for joining. Hopefully, there's some new opportunities, new ways of looking at product development, product creation, and maybe open up some doors with additive technology. I'd like to thank you all for joining. If you guys do have any other questions, please jump over to our 3D printing roundtable or visit us at the HP booth. Okay.